Okay, hey, it's Mr. Shrum, and I am using this document camera now to go over some of the mastery tests. So here we go. I printed off the sheet, write my name. Yeah, date, doesn't matter. Um, so this is all about vectors and scalars and learning how to use these numbers and correctly calculate different problems. So this first one is a statement about velocity. So we know a vector has magnitude and direction, while scalars only have magnitude. There's no positive or negative direction, right? So think of time. There's not negative time. Time is scalar. However, you can have a positive or negative velocity, and therefore that is a vector, okay? It's important to remember velocity is a vector. Other vectors include displacement, let's get that out of the way. Displacement, velocity, acceleration. Oops. Vectors. Okay, so they can be positive or negative values depending on the direction. Okay, I hope that's clear. Now, the second question, if a basketball travels a distance of 4 meters in 5 seconds, what is the average speed? So to get the average speed, you divide the distance by the time. And we're given the total distance and we're given the total time, right? The distance is 4 meters and the time is 5 seconds. So just divide distance by time. 4 meters divided by 5 seconds equals 0.8 meters per second. So you can use a calculator, or if you know your fractions, this should not be an issue. But yes, average speed, distance over time. Okay. Number 3. This one's a little more complicated, okay? But let's take a look at the situation. You're given all of the information you need in the question prompt. So a car is traveling at 20 meters per second and is brought to rest. So anytime you see rest, think of 0 meters per second. If something's brought to rest, it's not moving, okay? And if something starts from rest, that means it's starting from 0 meters per second. But in this situation, it's going 20 meters per second and then it stops, okay? So the initial velocity, the starting velocity would be 20 meters per second, and the final velocity is 0 because it stops, okay? It was going 20 meters per second, and now it's going 0, okay? So it's traveling at 20 meters per second, brought to rest by applying brakes over a period of 4 seconds. So it was going 20 meters per second. They hit the brakes. 4 seconds later, it stops, okay? What is its average acceleration over the time interval? Now, acceleration equals the change in velocity divided by time. change in velocity divided by time. So we take the final velocity minus the initial velocity and then divide that by time. Okay? So what was the final velocity? Well, it was brought to rest, so it's 0 meters per second, minus the starting velocity, which was 20 meters per second. So 0 minus 20, all divided by 4 seconds. That's the time it took to completely stop. So we have negative 20 divided by 4, and that gives you negative 5 meters per second squared. And a negative acceleration, all that means is that the change in velocity is negative. It's slowing down. And yeah, so any questions you see about acceleration, think of the change in velocity over time. And that's what the next one is about too. A car starts from rest, so that means 0 meters per second, and accelerates along a straight line path in 1 minute. So we know that 1 minute equals 60 seconds. So it's good to keep that in mind and write that down so you don't remember, or you don't forget to use seconds instead. So it starts from rest, 0 meters per second, and then it accelerates for 60 seconds. And then it finally attains a velocity of 40 meters per second. Starts from 0, a minute later, 60 seconds later, it's going 40 meters per second. What is the car's average acceleration? So this is like 3, but instead of stopping, you're starting from rest. So the starting velocity is 0 meters per second, and then the final velocity is 40 meters per second. So we'll use the same equation we used up here. Acceleration is the change in velocity over t. So final velocity minus initial velocity all over time. 40 meters per second minus 0, all divided by 60 seconds. And you get 0.66 meters per second squared. All right. So hopefully you're getting a feel for how these equations fit together, and you're understanding when things stop and start and how that affects the acceleration. And then we have 5. Which of the following is a scalar quantity? So I mentioned this earlier, but a scalar has only magnitude. There's no positive or negative. It just is positive. And that's time. Time, negative time, we don't really consider that in science. That's not a thing. So vectors are displacement, velocity, and force because they do have direction and they do have magnitude. But time is scalar. Okay. All right. 6. Now, this is a trick question, kind of. It's trying to catch you and see if you know the facts of gravity and air resistance. So suppose Galileo dropped a lead ball 100 kilograms and a glass ball 1 kilogram from the Leaning Tower of Pisa. Which one hit the ground first? And then this is the most important part right here. Assume that there is no air resistance. So what actually keeps something from hitting the ground at the same time is air resistance. If there is no air resistance and you're in a vacuum and you drop two things at the same time, they will actually hit the ground at the same time. Air resistance, not the mass, actually makes that not the case in the real world. In the real world, you do have air resistance, you do have friction, you do have things that affect the outcome. But strictly speaking, if there is no air resistance, these things will hit the ground at the same time. Okay, so you do have to watch out for these types of words or qualifiers, assuming there is no air resistance. And yeah, that's it for 6. That's I think the trickiest question here. And then 7, this is more basic vocab. Displacement, that is the shortest path between 2 points, including both distance and direction. Okay, so for instance, say you went up 3 kilometers and then to the right 4 kilometers. So this is your starting point, and this is your destination. So the displacement would be the shortest path between the 2 points in distance and direction. So that would be here. And if you use trig or geometry, you can find this distance, and that's the actual displacement. In the northwest direction, I suppose. 5 kilometers north and east, sorry. Northeast direction. But that is displacement. The total distance would be 3 plus 4. So that would be the total distance traveled. But the displacement itself is the shortest path between 2 points. Okay. So remember, there's a difference between total distance and displacement. Okay. Next question. Number 8. Jane is sliding down a slide. What kind of motion is she demonstrating? Okay, we talked about these different motions: translational, rotational, vibrational, transverse. Rotational motion, that means you're moving in some type of circular motion or things are rotating. Vibrational motion, things are moving back and forth. Think of a string on an instrument or things moving back and forth really fast. Transverse is a wave type of motion, oscillations, and none of those 3 sound like Jane sliding down the slide. She's just moving from one point to another via a slide. So that's translational motion. That's it's like the simplest of the motions, I think, to recognize. But Jane's just moving from point A to point B. And that's really all you have to do for that one. And then we have number 9. Which statement best illustrates vibrational motion? Vibrational motion I think the best example here that we use in everyday life or recognize are strings on instrument, even in a piano, cello, violin, guitars. That's a good example of vibrational motion. And lastly, here's number 10. John is traveling north at 20 meters per second, and his friend Betty is traveling south at 20 meters per second. If north is the positive direction and south would be negative, if going north is positive, going the opposite way is negative. What are John and Betty's speeds? So John is going north, and we just said that's positive direction. So John is going positive 20 meters per second. However, Betty's going in the opposite direction, so that means she is going negative 20 meters per second. Is that clear for everyone? If you say one direction is positive, then if you go in the opposite direction, that automatically makes it negative, okay? So all this is saying, John is going 20 meters per second one way, Betty's going the same speed, same velocity, but in the opposite direction. Same speed, opposite direction. Okay, and that is the walkthrough for describing motion. I hope that was helpful. Hopefully you understand these topics a little more, and I helped you out with some of the homework. Okay? I will see you guys later, and I hope you enjoy the rest of your day/week. See you later.